Hey there, welcome back. Today I'm working on a Powerstoke 6,000 watt generator. I believe this has a 14 horsepower Honda clone engine on it. And I got this generator about 6 months ago now. The recoil starter was broken on it, so I replaced that. But then I noticed that the engine was extremely difficult to turn over. This was the first time I learned about compression release valves on these small engines. So I suspected that it had actually blown apart inside the engine, and I was partly wrong about that. So I've done quite a bit of work to this generator. I have completely disassembled it. I will throw up a picture of the internals of the generator right now. And I cleaned it all out. The root cause was two things. One, it had very dirty oil in it, which caused the compression release spring to get gummed up and stuck. So that was one thing that was making it really difficult to turn over, because you would be getting the full 120 psi of compression that this engine should supposedly make. However, the other thing was I discovered there was a ton of dust in the cylinder that when I removed the valve cover, or that basically the head off of it, it was just probably a tablespoon worth of dust in there. And I really didn't expect that, but the cylinder was in great condition. There were no scratches, no scoring, so I just cleaned it up really good and put it back together. So now that's kind of where we are right now. The generator runs, and it produced power briefly, but then it stopped all of a sudden before I could do any real testing on it. And I tested the rotor on it, and I don't have any more resistance across the rotor. You should be able to get about, 50 ohms across the slip rings, and I'm coming up with nothing now. So that's what we are here today for. I'm going to start it up just to show you how the generator runs, and you'll be able to tell by this hour meter right in the center of the generator that should light up, and it won't. So that means that we're not getting any power. So this video will basically be replacing the rotor on a generator, and this should apply to just about any generator you'll be working on that's a portable one. I hope you learned something today, and I hope you enjoy the video. So let's get started. So I'm just going to take the back of this generator off to expose the rotor, and then show you guys with the multimeter that the slip rings have no resistance across them. Pop these off really quick. So we got our AVR, automatic voltage regulator. The stator getting connected here, and then there's our brushes right here, and then the rotor is right behind this bolt. So I'll just disconnect a few things here. Take the AVR out. The AVR is connected to the brushes. Pay attention to which one's black, which one's red. I believe it's pretty standard that the red goes on the left side here. So I already have pictures of these, so I'm just taking it off. Now I'm going to take pictures of the stator connections right here, and I'm going to take those off, and then I'll start filming again just to get some more room. Alright, so I got the wires out of the way now. I took pictures because I don't have great memory, so I'll be able to make sure that I put it together correctly again. And now I'm just going to remove the brushes, and you can already kind of see the slip ring in the corner there. I've tried to reposition the camera the best I can. So that's what we're going to be testing with our multimeter, which I have right next to me. But we'll go and pull these brushes off, and then go from there. brushes are just held on by this one screw. And it's out of the camera frame, but I've just got a metal or a magnetic tray here that I'm putting all the screws in so I don't lose them. And here are the brushes. They're not terribly low. I won't replace these because I don't have a spare one, but they still got quite a bit of life in them, so I think they're okay for now. But if they are much lower than this, I'd probably replace them. It's only about a $10 part anyways, but I think it's fine for now. So with the brushes out of the way, we can now expose the coils on this on the rotor here. See if I can get my fluke into a position where the camera will be able to see it. So I've got this on resistance and internal resistance of the multimeter. Pop these off. Internal resistance of the multimeter is about, my connectors are wet, 0.1, keeps climbing, about 0.3 ohms. Now we're going to test the rotor here, and I've got both contacts now, and it's nothing, just 0 across the board. So I'm pretty convinced that this rotor is dead because there's just nothing there, and there should be. So that's how you test to see if the rotor's any good. This one is shot. While I could probably get the rotor replaced without taking the fuel tank off, I will, just so that I can get a better view for you guys. To get this fuel tank off, there's just 4 bolts around the side, and then I'm gonna have to remove one of the little shocks. You can see the one right here. That kind of lets the handle rest down. It gets in the way when removing the fuel tank. Like I said, I already did this when I was replacing the, or just kind of fixing the engine. So we'll get to that. All right, the fuel tank is essentially free now. All we have to do is free the fuel line and this will come off. So this fuel shutoff valve is kind of just a friction fit in this front housing. So if you line it up with this notch in the plastic here, you can actually just push this through. Then it's good to go. And now down here, I'm gonna shut the fuel line off so that I don't have a tremendous amount of fuel dripping. And then I just need to remove this clip here, or just push it to a side. And now I can take this line off. There will be a little bit of fuel that drips out of here, but I've got a paper towel to catch that. And then there's very little coming out of the line here. So now I can just lift this fuel tank up. Like such. Next, I'm going to remove the 4 bolts that are holding this aluminum, I don't even know what it's called here, but this part right here, this is getting sucked on by these 4 bolts. I'm going to pop those off, and then we're going to remove this center bolt here. The rotor bolt is a 14mm head. I'm just going to use my impact and spin that right off. The last bolt we have are these 2 12mm bolts that are holding the engine to the shock absorbers, and then to the bottom of the generator stand here. So we've got all the bolts out now. What's next? Well, the way I'm going to remove the rotor is going to require for me to drain the oil. I probably could get away without draining it, but to just be safe, I'm going to go ahead and drain it. And that'll be clear in a little bit. But I've got it up on a stand right now, and I'm just going to, I've already got the oil bolt loosened. I'm just going to pop this off, and we're going to drain all the oil out of it. Which is pretty clean stuff because I just put it in. All right, we've got the bolts off, the oil is drained, now we need to pull the stator off. I have the stator supported underneath, or at least the rotor supported underneath by some wood here, and just because the engine's gonna be really front loaded when I take this thing off. And now I've got a puller on the front grabbing the aluminum casing, which is pretty soft. We need to be careful when you're taking these off. If there's any resistance, I'll use a rubber mallet and kind of tap around the outside to try to loosen it up. But I've already taken this off once, so it'll come pretty easy. And then the puller is seated inside of the bearing hole. And that is conical, so it's not going to mess up the edges or anything. It should be just fine. So I'm going to start just turning this pulley with a 14mm wrench, and I'm just going to be checking the outsides to make sure everything is moving smoothly. I actually got it started, so I'll just start pulling this off, and I can already see it moving. Very gently. And right there, I basically have it free. And that's it. So that is just a little bit left. Okay. The stator is free. Now I just need to lift it and gently remove it off of the rotor. Just making sure I have a good shot here. This is pretty heavy. I think this one weighs like 50 pounds. I might be wrong about that, but it sure feels heavy. There we go. So to remove a rotor off a generator, you have two options. One is you can put a rod down this hole that is two things. One, it has to be smaller than this diameter right here, right? Or else it won't fit. And two, it has to be larger than the bolt that you took out. Because if it's smaller than that bolt, two things could happen. One, it could mess up the threads at the very end of this rotor, which would then be really bad. Or two, that rod could just get a bad fit and bend and cause other problems as well. Well, so I don't have a rod, so I need to do a different thing. And I saw a fantastic method on James Condon, his channel, where he did this, and he used a bolt. I've already done this before, but this is an M12 bolt, which will thread in here, and now this rotor comes pre-threaded, so that's just super nice, or else you'd have to thread it yourself. So that threads in there. So what I'm going to do is I've got some plumber's tape, which I will redo, but we're going to tip this engine upright. We're going to put water in here till it fills up just to the very top, and then we'll start threading this bolt in. Now what that's going to do is, one, the plumber's tape is going to seal the water from coming out. So it's just going to build up a ton of, it's not hydraulic pressure, but pressure, and it'll just pop this rotor right off of the, it's a conical shaft, so it's a press fit. So that's what I'm going to do. I'm going to tilt the engine up. We're going to fill it up with water. I'll try to get a view for you guys, and then I'll retape this bolt as well off camera, and then start threading it in. So we've got the generator tilted back. I've already added a little bit of water into this cavity right here. Just top it off. And I've got my bolt with some fresh plumber's tape, and it takes quite a bit of plumber's tape. This is on here pretty thick. I've got the first few threads kind of exposed, and then it gets really thick. So let's see if this works. Trying to stay out of the camera's way. Now if I do this right, this should pop pretty soon. Oops. There we go. Just like that. Now I can remove the rotor. So I brought the two rotors over to my desk to show you guys them side by side. From the research I did, it really seems like the one I bought is the correct rotor. There are no serial numbers on these things, which is kind of frustrating. So I just had to go off of parts diagrams that I had available. Now, of course, there are some physical differences. The bolts here, are in different positions, and the slip rings are at slightly different heights. But based on the wear pattern of this one here, it seems like the higher slip rings on this won't actually cause a problem. It might actually line up a little bit better. But here's a really interesting thing when I took these over here, and I was looking at the older one. I found the problem, and it's right there. Half the coil, or that one side of the coil that attaches to one of the slip rings, has come loose. Just broke off. And now I'm really wondering if I can fix that. So there have been two developments since last night. One, the new rotor doesn't fit, so I'm returning it because the place I bought it from advertised it improperly. And two, I've been forced to fix this one. Now, what you're looking at is ugly. This is an abomination to what the original manufacturers intended. However, it works. So I got new wire, and it doesn't need to be insulated because it's not exposed to anything right here. I've got new wire. It is soldered to the tab here, and then the old wire that was left, I wrapped it around this plastic part right here, and then I took new wire, wrapped it around, and then soldered it all together. And as a result, zoom out a little bit here. As a result, we have continuity across the slip rings. Sitting around 56 ohms, and that new rotor was at 55 ohms. And I'm really happy with this. This will stand the test of time right here. That's not going anywhere. So, while it may look ugly, it works. So I'm going to start putting this back together and see where we go from here. To assemble the engine, we basically do it in reverse order of what we did before. So I'm going to put the rotor on first here. Just drop that into position. And then I'm going to take the bolt. I'm just going to lightly tighten this down just enough so that, you know, I know it's holding well and everything's straight for when I put the stator back on. Okay, and now it's time for the stator to go back on. So you can see right here, the bearing from the rotor has to seat probably another 1/4 inch into here. So to get this in the rest of the way, I'm going to put a piece of wood right here and then probably tap around different locations to try to get the stator pushed into its original spot. Okay, I've got the spark plug out. So I'm just going to slowly pull the cord and make sure I don't hear any grinding. Sounds good. I just put the shroud back on really quick. It just has the model number of the generator. And now I will put those bolts back in. So I got this mostly put back together. I know if you skipped a few steps, but I figured it was pretty self-explanatory. Basically just take things, put things back on the same way you took it off. So, you know, I've got the AVR exposed and some other things just to make sure that everything checks out when I start it. And to test, I just got a 1,500 watt heater right here, and then a light bulb attached to my Harbor Freight kilowatt here as well. So I'm gonna fire it up and see if we have power. It's running a little high. I'd like to see the hertz at like 61.5, give or take. So I'm gonna dial it down a little bit and then let's do one last show of how it's running. I forgot that this engine had the tab style of governor where you don't actually have to turn in a screw, you gotta bend this tab back. So it took me a little bit to dial that in, but I think I got it now. So let's fire it up and check that really quick. So good. I'm just gonna do the rest off camera here. I just need to assemble a few things here and there. But this generator is good to go. Thanks for watching. I hope you aren't too critical of my very rough repair on that rotor, but gotta do what you have around, right? So, I think it'll be okay though. I don't think that'll be failing anytime soon. So thanks for stopping by. I hope you learned something, and have a good rest of your day.